Hello everyone, I'm Matt. And today I'm going to show you how I built this wire winding machine. I was actually tasked with building a machine that would wind wire on a coil in two directions. So it would wind, say, clockwise, and it would stop and wind anti-clockwise without unraveling. So this is the idea I came up with. Might not be the best, but it works. So the way this works, as you can see, this little rod here has like a fish hook on the end, and that goes in this body here, and this can rotate, and this is adjustable. We get our copper wire that's fed to the back, comes over, and this little fish hook grabs on. Then this rotates while this feeds. Then if we want to change direction, we always push this rod out, gotta make it come over and grab on, and then we can rotate the opposite direction. You can see how we haven't unraveled.
All of the design work was done in Fusion 360. The goal was to have all the parts cut from 3 and 6mm acrylic and off-the-shelf components. My design process usually starts with a rough pencil sketch to get my ideas out of my head as quickly as possible. Once I have a basic idea of what I'm building, I'll use Fusion 360 to draw a rough digital mock-up just to digitize my drawings. Then I measure and design every part of the project, each in a separate part file. This way, I can create an assembly and import each part individually. This makes it easier to update each part, and it also allows me to reuse parts in other projects. Once I have all the design work done, I'll export all the parts that needed to be laser cut or 3D printed. Here I'm just setting out some of the parts I need for the project. It's going to use 2 TB6600 drivers, 2 NEMA 23 stepper motors, a 24 volt power supply, and I'll also be using a Makerbase G-code controller. They're designed for 3D printers and laser cutters and have way more options than I'm going to need. For this I just need X and Y outputs. The original design used a cheaper offline controller with a wired keypad, but the issue with them was they didn't accept all G-code commands. Most importantly, it didn't allow for pausing mid-program. I got around this by generating multiple G-code files for each part of the process, but it needed a lot of button pushes to wind one coil. With the Makerbase controller, I can set it to pause mid-job in the G-code, so the program will stop when you need to change the winding direction with the fishhook. Then you can just hit the play button to continue to the next step. This is a handy tool for electrical work. It's called a bootlace ferrule crimper. You can get cheap kits that come with a whole bunch of different sizes, and the crimps go onto the end of a wire to make a rigid end, just like a shoelace. It makes it easier to insert into terminal blocks and improves the durability of the connection. Now that motor at the back, it's got another 3D printed part on the front that actually feeds the wire on. So in the G-code I can tune how far that moves left and right, or what angle. It took a lot of trial and error to get that right. Here I'm just checking the way the switch works with a multimeter so I don't wire it up backwards. I'm just sticking down the components with double-sided tape for now, because I know I'll be disassembling and reassembling this multiple times before I'm finished. This is a 3D printed part that actually does the winding. It's got 2 bearings on each side and a solid rod that's permanent in the middle. And then you have another rod that slides in and out, that's the fish hook. These two plastic covers just retain the bearings. The 3D printed part in the middle holds them in the middle, but the plastic part holds the outside. So basically that 3D printed part can't move left or right, it's locked in that position. Here I'm just cutting up some threaded rods so we can squeeze the body of the machine together, kind of sandwich the whole unit together. Each piece of acrylic has a nut on each side of it, just kind of locks everything in position, makes it really nice and solid. So this was the first test. So you can see you got to adjust the positioner at the back all the way to the right. You got to put a little sleeve onto the main rod. That way it makes it easy to remove it afterwards. Then you feed it through. You wrap it over the top. Grab it with a fish hook, and bend it out of the way, and then hit play, and away it goes. This wasn't the only unit I built. That one there was the first prototype unit. I used an Arduino, but found the G-code controllers were much easier to use. I ended up building 4 of them, and eventually upgraded them all to the touchscreen controllers.